All right, so in this video, we're going to talk about square roots. So the first thing you should know is that the symbol used to denote a square root is this. And you can take a square root of a number. And that is going to be the same thing as raising it to the 1/2 power, which is also equal to y. Also, the square root of a number n is equal to m when m squared equals n. So m times m equals n. All right, now there can be two possible answers when you're taking a square root. There's going to be a positive answer and a negative answer. And that's because if you go backwards in this, so you take, let's say for instance, let's use 2. And you take 2 squared, that's going to equal 4. Because that's going to be 2 times 2, right? Which is equal to 4. Now, if you take a negative 2 and you square it, that's the same thing as negative 2 times negative 2, which is also positive 4. So it gives you the same answer. So if you were to take the square root of 4, you could get a positive 2 or a negative 2 as your answer, which is denoted by plus or minus 2, just like that. All right, so let's just learn now how to simplify some square roots. So if you have the square root of 9, let's say, you're going to go ahead and run a prime factorization on 9. So we've got 3 and then 3. And anywhere you can take a pair, you bring it to the outside of your square root. So we're going to have 3, and then there's nothing else, so our answer is just 3. Now, if we had the square root of, let's say, 24, then you're going to run a prime factorization on 24, so 2 times 12 is 24, then 2 and 6, then 2 and 3. Circle any pairs that you have. And those go to the outside of your square root. So 2 square root, everything that's not paired up gets multiplied inside the square root. So 2 times 3. So the square root of 24 is actually equal to 2 square roots of 6. Now, if you have the square root of 48, run a prime factorization, so 2, 24, 2, 12, 2, 6, 2, 3. Circle any pairs. So in this case, we've got 2 sets of 2. So on the outside, we're going to have 2 times 2, then our square root sign, and then 3. So the square root of 48 is actually equal to 4 square roots of 3. All right, so any pairs go to the outside of your square root. Anything left goes to the inside. And any pairs, again, are multiplied against each other. Anything that's not paired is multiplied against each other. So that's how you simplify square roots. Now, if you had, for example, let's just go with 102 x to the 6th, then you go ahead and you want to know the square root of that whole thing. You go ahead and run a prime factorization on this. So 102 x to the 6th, 2 and 51. 51 divided by 3 and 17. And of course, these have x to the 6, x to the 6. So then we're going to have 17x x to the 5th, x to the 4th, x cubed, x squared, x. Then you can circle any pairs that you have. So on the outside, we're going to have x times x times x square root of 2 times 3 times 17. So that's going to be x cubed square roots of 102 is going to be your answer to that. Now, there are a couple properties that go along with square roots. And so if you had, let's say if you had 20 times 2, square root of that whole thing, that's the same thing as being the square root of 20 times the square root of 2. And then you can go ahead and run your prime factorization on both of these and simplify it. And then same goes for when you're dividing. So if you have the square root of 20 over 2, then that's the same thing as the square root of 20 all over the square root of 2. Again, then you run your prime factorization on both of those and then simplify accordingly. Now, the last thing that you'll have to deal with as far as square roots go is solving equations that contain square roots. So, the square root is the opposite of something being raised to the power of 2 or something being squared. So just how like addition is opposite to subtraction or multiplication is opposite to division, same goes for this. So like when you had an equation like x plus 3 equals 5, to get this over to the other side, we did the opposite of its sign. So here we have addition, so we're going to do subtraction on both sides. So that's the same thing that we're going to do with square roots and squares. So if you had something that was like x squared equals 25, to undo the squared, you just take the square root of both sides. Now again, the square root is like raising it to a half. Right? So then that's the same as x 2 times 1/2, which is just equal to x to the 1. So x is equal to 5 because we ran our prime factorization over here. Got our pair of 5. Right? So again, you just take the square root of both sides. Now, that also applies if you've got something, say you've got the square root of x equals 6, and you need to get x all by itself, you can come in and square both sides. Again, this x is like x to the 1/2 squared, which is equal to x times 1/2 times 2, which is equal to x raised to 2 over 2, which is x to the 1, which is just x. right? And then 6 squared is 36. So x equals 36. So let's go ahead and run through a full example. Let's just say we've got, let's do x squared plus 10 equals 110. So again, you're going to subtract 10 from both sides. And x squared equals 100. And then at this point, we've got a squared that we've got to get rid of. So you take the square root of both sides. And that square root and that squared will cancel, so you'll be left with x. And then you can run a prime factorization on 100. So x equals 10, because it equals 2 times 5. So x equals 10. And again, that can be plus or minus 10 in that case. So that's just a little intro on square roots.